Infrastructure as a code, a very important aspect of complex and reusable infrastructures. So our next speaker will talk about how to implement Zabbix with MySQL in Oracle Cloud by using Terraform. Let's welcome Vittorio Cioe from MySQL Oracle.
Hi everyone again. This is Vittorio and I'm here to talk to you about Zabbix and MySQL database service in Oracle Cloud, but this time we are going to see how infrastructure becomes code. So, I am very happy to be here at Zabbix Summit, unfortunately still in digital presence, but hopefully next year is going to be the right year to be back all in Riga. For those of you who don't know me, I am a Linux and MySQL user since 2006, and since 2017 I am working as a MySQL solution specialist at Oracle. I regularly appear at conferences, so I am happy to be a regular guest of this conference as well. I am originally from Italy, but I am based in lovely Warsaw. Alright, what we will speak about today? We'll see how to deploy Zabbix with MySQL database service as code. We will actually build it, and we will see target architectures which we can do with those building blocks, and then we'll see what's next. So, deploying Zabbix with MySQL database service in Oracle Cloud as code. For those of you who are not new to this conference, do you remember my previous talk about Zabbix in Oracle Cloud? So we went over how to deploy Zabbix server into Oracle Cloud infrastructure. And do you remember MySQL database service? For those of you who weren't here, just a brief recap. MySQL database service is a fully managed database service out of Oracle Cloud infrastructure based on MySQL Enterprise version 8, so fully compatible with on-prem, with support, with 100% developed and managed by the MySQL team, with high availability, inbound, outbound replication, analytics. A lot of the cool feature we love on-premise has been ported also to the cloud. But what about deployment as code? What is that? So, in Oracle Cloud, you'll have the possibility to choose how to deploy your components, either as infrastructure items from the interface, or you can deploy your infrastructure as code thanks to the Terraform integration, which is natively present on Oracle Cloud. So we can see from the slide how some infrastructure component, like the whole of the networking, the MySQL database, the virtual machines, will become reusable code and will give life to an infrastructure as the one you see on the right, but not only to one infrastructure. They can give life in the span of minutes to as much infrastructure you desire. So the good advantage of this is that it's reproducible. Alright, we have seen it, now let's go build it. We need to see all of the building blocks which we need to deploy Zabbix server MySQL database in a cloud environment. So, what might be the first thing that we need? Of course, we need to know how to build Terraform code, a bit of structure. Without that, we don't go anywhere. There is plenty of documentation online about how to code with Terraform, but here, some good practices for who is at the beginning. We can use three different files. One, the main file, where we will actually put all of our infrastructure items. One, the variables file, where we will declare all of our variables, and another one, the tf-vars file, where we will give a value to the variables. Now, The first piece of cloud infrastructure that we need is the virtual cloud network, the VCN. So here you have an example on how actually build a VCN. So we can see it's quite easy. We have just to declare the VCN compartment, and in the locals we can retrieve some interesting values like the VCN ID, DHCP option, and all those things which will come useful later on. Next, we need the gateways. So for a network to work, we need internet gateway, NAT gateway for the private subnet, and service gateway. And we can retrieve also some IDs in this case. We need route tables, of course, for our routing to work. Alright, we need route tables. Here we see how we declare the route tables. And we need two of them, one for the public subnet and one for the private subnet. One for which will direct to the internet gateway, and one which will direct to the NAT gateway. We need again security lists for our subnets, which we are going to build in a while. So here you have how it's a security list declared. What we need for a security list? We need security rules to be allowed, so basically firewall rules. So rules will be needed for SSH connection, MySQL database port, Zabbix frontend, Zabbix backend, and eventually Zabbix proxy. Different subnets equal to different security lists, hopefully. Again, finally, we have the subnets. So we need two subnets, one private and one public. The public to receive incoming connection from the outside, and we need private subnets. One, if we want to go simple, we'll see. More than one if we want to build a more extensive architecture. So this is how a security list is declared. So far we have understood one key thing about Terraform deployments. It's a declarative language. It is simple. You copy the block from the documentation, you declare the corresponding variables, you give a value from the corresponding variables, you put the variables into the code, boom, done. I have zero experience in development, and I was able to develop hundreds of lines of code in a very small, short time. So this is really simple, easy, and accessible to everyone. Again, now, our special guest, MySQL database service. So, to deploy a MySQL database service on Terraform, it's very easy. We declare the admin user, admin password, we declare the availability domain, we declare the compartment ID, the configuration ID, which we need to retrieve, and in some code samples I'll provide later, we'll see how to retrieve, you'll see how to retrieve that. We need the subnet ID, so all things which we have retrieved so far from the previous executions and from the previous block of code. Then we need to declare if we want high availability or not. So high availability, if we want it, we will equal the parameter is highly available to true. We will declare the ports. Very easy, natural, declarative. Compute instance. Alright. We need to declare a compute instance, so a VM, inputting again several parameters like the compartment, the shape. Again, there is a procedure to retrieve the shape, which is explained in which is visible in the samples of code I provide later on. And we create a VNIC, we declare the operating system which we want. So we input again several parameters, and then we have to be careful with one parameter which is called user data. Yes, in the user data we can put cloud-init. So, what is cloud-init? Cloud-init is actually the main tool which will allow us to deploy an already functioning and configured Zabbix server without having to configure it ourselves. Cloud-init is an industry standard for cloud post deployments, so it will give to the newly deployed VM commands to execute. You can see the cloud-init syntax is not difficult. Anyway, you can use the skeleton of what I provide you on the slide, which is a workaround to do cloud-init in a smarter way. So basically, if you have special characters in cloud-init, you have to escape several things with slashes, and I personally lost track of how many slashes I've put. So what I've done, I have created a banal, trivial Unix script which I have been using to configure the Zabbix server. So a Unix script which does all of the configuration, and then I have encoded it in base 64, and I have encoded the piece of cloud-init already in base 64. And when I've done this, I have automated the deployment. So here I provide you a sample of cloud-init, of the script which I have used for cloud-init. So I have you can go through this, it's very easy. We wait for the database service to be created. We disable SE Linux and the firewall. We download Zabbix and MySQL clients. We create Zabbix database, and we configure the server.conf via some sed operations, and then we configure the front end to escape all of the graphical configuration part, and we enable the service. We're done. This script will deploy will configure server plus front-end on one VM. You can reuse it as you wish. And if you encode it in base 64 and put it inside cloud-init, well, you're good to go. Now, a couple of useful tools to do all of this. OCI Designer Toolkit, which is an open source tool where you drag and drop architectural diagrams, and then you convert them into working Terraform code. To do what I have done with Zabbix, you will have to rework a bit, but it's a way to learn Terraform starting from the other side. And OCI Resource Manager, which will take your OCI deployed infrastructure and will convert it into Terraform code. Now, target architectures as code. A simple target architecture, very simple. One Zabbix server with front-end, one database. That's it. With all the network accessories. We can enhance that architecture. We can add two Zabbix front-ends, decouple from the server, and we can add a proxy in another subnet to accept additional client connections. And we can use MySQL database service with high availability. And if you are curious to try something already done, I have provided on GitHub a couple of examples which you can find at the link here, and you can choose which architecture you want to deploy. If you want to deploy the simple architecture, or if you want to deploy the more extended architecture which I provide. So on one side you have front-end and server on one machine in MySQL database. On the other you have decoupled front-end from the server. You have still MySQL database with high availability. And you have on a different network the Zabbix proxy. So additionally, you will see also how to implement VCN network pairing, and you will see an example of VPN connection to an on-prem environment. So you can go to this GitHub, to my GitHub page. It's all documented. It's all available for you to try. What's next? Well, start building. You can start building around MySQL database service for free today, getting a $300 trial. If you contact with me, the $300 can become $500, and you can try all of the Oracle Cloud, including MySQL database service, free for 30 days. So, any questions so far? I'll be here still to take questions, but I would like to thank you for the attention and hopefully see you the next year back in Riga.
Thank you, Vittorio, for a great technical speech. This actually has been a great learning experience for all of us. As for the questions, feel free to use the chat and Vittorio will respond to you with the answers to your questions. Thank you.